In this short video, we're going to discuss respiratory gases and the effect that those gases have on pH of body fluids. Now remember, pH is simply a measure of hydrogen ions in a solution. You know that you breathe in oxygen, and when you exhale, you get rid of CO2. So I want you to try a little experiment first. I want you to stop and hold your breath. Hold your breath and don't breathe until you absolutely have to. I do this in class with my students. Are you holding your breath? Hold it, hold it, hold it as long as you can, and when you have to release, I want you to notice the first thing that you do. Did you inhale or did you exhale? Most of the time, when you have to stop holding your breath, you will exhale. The reason for that is you're building up CO2. So you exhale to get rid of that CO2, and then that is followed by inspiration or inhalation to get more oxygen in. Now, why did you stop holding your breath? Could you continue holding your breath until you died, maybe? I don't know. Most people can't. So when your toddler says, I'm going to hold my breath until you buy me that truck, let them hold their breath. Your respiratory center in your brain and your pons and your medulla will take over and trigger to breathe, trigger the breathing action. So at worst, what's going to happen? They'll pass out for a second and then they're going to start breathing again. All right, so I tell you all that to lead to the point of some of the exercises that we typically do in lab. So when you are holding your breath, you are increasing the level of CO2 in your body fluids. That in turn leads to a decrease in oxygen in those fluids as well. Think back to the pH scale. You had body fluids that were at a normal value of 7.35 to 7.45. which is a little bit on the alkaline side of the scale, because remember, 7.0 is neutral. So if you increase CO2, you're pushing the pH of body fluids down the pH scale, and they become more acidic. When body fluids, such as blood plasma, become more acidic, then you have a decrease in the amount of oxygen that binds to hemoglobin. So when you learned about blood back at the beginning of this semester, you should have talked about or learned about things that decrease the amount of oxygen that the blood is able to carry. pH is one of those factors. So in our lab, we're going to look at a couple of different exercises. Whoop, too fast there. One is using a pH indicator called Phenol Red. So Phenol Red is a pH indicator that is normally sort of just a translucent red color. But when that Phenol Red is in the presence, or when excess changes in pH happen, the color changes. So if that Phenol Red solution becomes a bright pink, that indicates that pH has increased and the solution has become more basic or more alkaline. When the color of the solution goes from a red to a yellow or orange and then to yellow, that indicates that the pH of that solution has gone down. And remember, a lower pH indicates more acidic. And of course, the solution is naturally a red color, and that is indicative of a neutral pH. So in lab, we can take the Phenol Red and put it into test tubes, and then take a regular drinking straw and blow bubbles, just like you used to in the lunchroom, right? You would blow bubbles through your straw into your milk. Well, if you do the same thing, you put your fingers over the top of that test tube with the straw between your fingers. All you're doing there with the fingers is creating a barrier so that you don't blow and the Phenol Red splashes up and onto you, right? So you put the straw between your fingers and you exhale, you blow into that straw. Now, as you do so, the CO2 that you are exhaling is going down into that test tube and into the solution. And as it does so, you'll notice that the color of the solution is changing from red to yellow. So the increased CO2 leads to a decrease in pH, and the solution becomes more acidic. Now, let's think about what might happen if you add baking soda to that solution. Baking soda contains sodium bicarbonate. That is an alkaline substance. So what would you expect to happen to the color of the solution? Exactly, it would go to a bright, vivid pink, sort of a purpley pink, and that shows you that the pH has risen and becoming alkaline. So let's look at this short little equation that explains what's happening here. So we have lots and lots of water in our blood plasma. CO2 is created as a byproduct of normal cell metabolism. So the CO2, remember, is the waste product that's picked up from the tissues by the blood and then is returned to the lungs so that you can exhale it. So when water in your plasma combines with that CO2, it creates carbonic acid. Carbonic acid, H2CO3, is very unstable, so it breaks apart really easily. When carbonic acid breaks apart, it releases hydrogen ions and bicarbonate ions, okay? Now, anything that releases hydrogen ions into a solution, by definition, is an acid. So when you have an increase in CO2, there's plenty of water available in your body fluids, right? So you create more carbonic acid, which dissociates to release those hydrogen ions. So your pH then drops and becomes more acidic. So that's what you're seeing here with the Phenol Red pH indicator. Another exercise that we do in lab is to hypo and hyperventilate. So hypo means low, under, below normal. Hyper means above normal, more than normal. So if you hypoventilate, for whatever reason you have very shallow breathing, or you are re-inhaling CO2, such as you see here in the image, well, what's happening? You're accumulating CO2 in the blood rather than exhaling it into the environment. So that increase in CO2 drives pH to drop and body fluids become acidic. So you're going into a state of respiratory acidosis. So if you measure how long you can hold your breath under normal conditions, you'll find that you hold your breath for a certain period of time. But what if you breathe very shallow, or you bag breathe and you're rebreathing that CO2? Well, you already have created a state where your pH of your body fluids, your blood, is more acidic. So you're not going to be able to hold your breath for as long because you already have high levels of CO2, right? Makes sense. But what if you do the opposite? If you hyperventilate, you're breathing very rapidly and getting rid of excessive CO2, more CO2 than normal, you decrease the level of CO2, which makes your blood pH become more basic. Now, if you hold your breath and you time it, you'll find that under most conditions, you'll be able to hold your breath longer. Why? Because your CO2 levels were lower, and it takes longer for that CO2 to build up when you're holding your breath, right? So you can hold your breath longer to get pH back to normal. All right, so this was a short little video to explain the effects of respiratory gases on body fluid pH.